Okay, today we're in section 13.2. This lesson is going to be split into two parts. Okay, today we're doing the first two examples. Technically three examples, I guess. And it starts off with some important information, okay? Before you get too overwhelmed, there's a lot to write. It kind of does all work together. All right, it's not too bad. Just kind of follow me step by step. The slope of a line, you need to understand what that is. What does that even mean to find the slope of a line? It is the rate of change between two values. And those two values are your x and your y values. With any linear equation, you guys remember, what does it mean for an equation to be linear? What does that mean? Just tell me.
It forms a straight line.
It's a straight line. So when that happens, there is a clear connection. There's something happening to my x value to make y. And when that happens, I have a slope. I have something that I can use to actually predict future outcomes. Okay? All right, so it's the rate of change. Okay? What does that look like? In its most basic form, it means rise over run. M stands for slope. It's rise over run. All right? What does rise mean? It means the change in the y value divided by the change in the x value. I'm going to show you that in the next example. Okay? And a formula that can work to find that change is this formula right here. Y2 minus y1 over x2 minus x1. That looks kind of foreign right now, until I can kind of show you how the sequence breaks down. That's not going to make a whole lot of sense. But for now, I just want you to copy it down. Okay? Just copy it down. We're going to revisit it and explain how I can identify which value is my y2, my y1, and so forth. All right? So you do want to copy that down. All right? And I'll give you a minute just to kind of get caught up to that point. Don't write anything down here yet. All right, because we're going to kind of abbreviate that. Okay, I want you to write 4, all right, of the XY, hold on, I'm looking for my highlighter, of these XY axis, okay? Just write 4 of them next to each other. 1, 2, 3, and 4, okay? You're going to kind of write those. It's just your XY, and then you're showing them connected. We're not numbering anything. All right, just kind of set them up, okay? 4 of them. And then above each one, I want you to label them like they're labeled here. Positive slope, negative slope, slope of 0, undefined. All right, this is really important that we understand what's happening based on how the line is angled on my graph. Okay, but there's one thing that's really, really important, is that I read these graphs from, what does it say underneath? Left to right. From left to right. You see, guys, if you read it backwards, you're going to say it's the opposite of what it actually is. From left to right, I want you to draw an arrow that's sloping up. From left to right, that is what we call a positive slope. Why? Because it's going up, right? Okay, so that's kind of common sense. So see what's happening with the negative slope. From left to right, which way is it going? It's going down. See that? What's happening with a slope of 0? What kind of line is that? Horizontal. It's important that you label that. A horizontal line has a slope of 0. We're going to revisit that here in a couple minutes. The last one shows a vertical line, and we say this vertical line has an undefined slope. You need to label it vertical. You need to make sure that you have it labeled undefined. It's very, very important, okay, that we can identify the difference between the two, and there's a couple key differences. All right, so we pretty much did write down the entire slide, but we're just breaking it down. All right, these are really, really important information. Really important, especially if I had to pick what's most important, it might be this formula up here. All right, this formula is really a foundational piece to finding slope. All right, just like I told you in 13.1, y equals mx plus b, that's like really, really important. this formula is very important to find slope. You're going to hear it over and over again. I know it might not seem like it right now, but by the time you get to this test, you're going to know this like the back of your hand. I can almost 100% guarantee it, okay? So it's something that with practice, it becomes much easier. And you'll find yourself kind of surprised at kind of how automatic it becomes. But to get there, we got to practice, all right? So that's what we're going to do here in example 1. You do not have to copy down the graph, okay? You do need to turn in your book, all right, to page, let's find the page. Page 562. Turn in your books, page 562. I should see them open. All right, here's what I want you in your books. To me, if I can like kind of put, not draw in my book, we're not writing in our books, right? But if I can kind of put my hands on it, and count instead of having to count up here, the blocks, that makes it a little easier. But I need to explain to you what's happening here, okay? There are 2 methods for finding slope. I'm all about, in my teaching philosophy, giving you the easiest way to get to your answer. Is that okay with you guys? So when you have a graph in front of you, 3 problems on your homework tonight, this will be on your quiz on Wednesday. If you have a graph and a line plotted on that graph to find slope, the easiest way to find the slope is to use the formula rise over run. Rise over run. Remember, there's 2 ways to find slope. One of them is to count rise over run. When there is a graph, this is by far the easiest way. M equals rise over run. Now, we need to think of rise over run in terms of X and Y. So rise, this is really important, guys. Rise is my Y values. Run is my X. So this is Y over X. What do I mean by that? Between the 2 points. So from left to right, does everybody agree? I just drew the arrow that is your first point on the graph from left to right. Okay? So between your first point and your second point, what is the change in the rise? Meaning the change in your Y value. You go from a starting Y value to an ending Y value. We need to count that rise. Here's how it works. 1, 2, 3, 4, and 5. I made a rise of 5 units, okay? And does everybody agree now it's parallel to the end point? Okay, so I rose 5, so M equals 5 over, and now I count my run. 1, 2, 3, 4, 5, 6. My run is 6 units, so my slope is 5 over 6. And that's what it actually shows you the opposite way. My complaint here is that they do run and then rise, and I feel like that's confusing because it's supposed to be rise over run. Okay, so I always count my rise first. And guys, it's positive. Does everybody agree? From left to right, it is sloping up. Everybody agree? But here's what I want you to notice. It's the rise that is positive. The run is always going forward. It's the rise that's positive, and it's the rise that would be negative if it were negative. Here, it's not negative. All right? You guys with me so far? Following along? So let's look at the next one. Again, you're right there in your book, but I'm walking you through and explaining what we're doing here, counting rise over run. In your book, it uses the formula. That's not needed. We have a graph in front of us. We can count rise over run. Okay? So, same thing. Left to right. I want you to pinpoint, kind of with your eyes in your book, from left to right, what is your first point? Put your finger on it in your book. Did you pick this point right here? Okay, you should have. All right? And then this is your second point. You've got to have a starting point from left to right. Okay? So now we need to count our rise from the first point to the second point. Now which way am I going? Down. So my rise is -3. And how many do I run? 1, 2. So my slope is -3/2. It cannot be reduced. Now, do not change this to a mixed number or a decimal, because then you lose your rise over your run. That's not going to completely make sense until we start graphing, okay? But just remember, we keep this as a fraction. -3/2 is my final answer. Don't make it a mixed number. Don't make it a decimal, okay? Reduce it if you can, but leave it improper. We have a graph. We're going to count rise over run. I want you to do one on your own. You guys are in groups. Get your answer first and then compare your answers. If someone's answer in the group is different, you have to decide who is right, who is wrong, and all come to an agreement. Okay, I'll be walking around helping you guys. So it's really important that we read this left to right, which means which point comes first? Yes, -2, 3, and then I'm going to 3, 2. That is significant because to go from the first point to the second point, am I going up or down? Down. I'm going down how many units? 1. So rise over run. I'm going down 1, so that's a -1. And how many am I running to get to that next point? 5. 1, 2, 3, 4, 5. So it's -1/5. Okay, so it's -1/5. All right. Now, guys, this is a totally new concept, so just hang in there and we'll kind of get through it. Okay. All right. Example 2. So that's how I do it when I have a graph. That's how I would find slope. But what if I don't have a graph? What if all I have are ordered pairs? Now, it's a true statement that I could plot these points on a graph and then count them, rise over run. True statement? Okay. However, by the time you get them on a graph and count, if you use the other method, which is a formula, you'd long have, had your answer and been on to the next problem. So again, like I said at the beginning of the lesson, I'm all about giving you the fastest way to get to your answer. If all you have are ordered pairs, you are going to use the formula. Y2, okay? So under example 2, it's not a bad idea to write your formula again. M equals Y2 minus Y1 over X2 minus X1. I've got to explain this to you, and it's very important that you're listening, okay? Your Y values are your change in your rise, and your X values represent the change in your run, okay? So, in order to figure out which one's Y2, which one's Y1, I need a sequence. This sequence will always be the same. You will always have 2 pairs that you're dealing with. And here's your sequence, all right? So go ahead, if you haven't already, write this first set of ordered pairs. 6, -4, and 2, 6. So again, you're always going to have 2 ordered pairs. If you don't have 2, then this does not work. And your sequence goes like this. The first ordered pair is X1, Y1. The second ordered pair is X2 and Y2. All right, why is that? Well, in my first order pair, this is my first X value. That's why I call it X1. -4 is my first Y value. That's why I call it Y1. Then in my second one, that's why it's X2 and Y2. All right, and it's that way every single time. I could give you 100 of these, and the sequence will always be the same. X1, Y1, X2, Y2. Now that I have a sequence, I can plug these values into a formula. Which one of these numbers, these 4 numbers, is my Y2 value? 6. Does everybody agree? 6 is my Y2 value. So that's why I plug it in. M equals, I plug it in where Y2 goes in my formula. Minus, what is my Y1 value? -4. So look what happens, guys. Minus is already in my equation, my formula. So what happens when I minus a negative? The negative cancels. Yes, I think that's what you meant. Okay, so we'll deal with the double negative in a minute. Just leave it there. Leave it looking weird there for just a second. Okay? Over which one is my x2 value? 2 minus what's x1? 6. Now I'm ready to simplify. 6 minus negative 4, double negative changes to a? What's 6 plus 4? Okay? Over what's 2 minus 6? Negative 4. Okay. Remember what I said about where that negative can go. All right, we'll deal with that in a second. Can I reduce, not change to a mixed number, but can I reduce this? Yes. What can I reduce it to? No. 5 over 2. Okay? Now, the negative will never be connected to the run. Every once in a while, we see that negative in the denominator, but we are going to move it either to the numerator or out in front of the fraction. It actually doesn't change the value, but we recognize the rise is what is negative, never the run. Negative 5 over 2. Okay? All right. Now, on the next one, I know we're kind of early in this, so if you're still lost, that's okay. All right? I want you to try to make your substitutions into the formula. All right? Again, the sequence never changes. It still goes x1, y1, x2, y2. Try to make your substitutions into the formula. Right, so what's my y2 value? M equals what? 5, y2 minus 8 over negative 4 minus 4. All right, you do have your calculators. Use them to double check, but can we do this mental math? Yeah. Absolutely. 5 minus 8? Negative 3. Negative 4 minus 4? Negative 8. What happens when I have a negative divided by a negative? Not a double negative. This is not double. But dividing two negatives is a positive answer. All the time I have students say, this is a double negative. This is not a double negative. A double negative is two negatives in front of one number. But this is two negatives, which is even, and that is a positive slope now, 3/8. And guys, that makes all the difference between a positive and a negative slope. All right, any questions? How are we doing? How are we doing, guys? Hey, up here, how are we doing? Okay, so let's do now the second part of example 2. Something is going to be different about these slopes. And the hint is in the title of this slide. Horizontal and vertical lines. So we're going to use our formula. Again, this is 2 more problems that we're using that formula. Y2 minus y1 over x2 minus x1. But something's going to be different about our answer. We have to be able to recognize it. Okay? So I'm going to kind of leave you on your own now because this is the third one where we're plugging it into the formula, and then get to your answer, and then we're going to take it one step further. I'm going to show you what's happening in a horizontal and vertical line slope. Okay? But go ahead, guys, and plug these values into your formula. Okay, all right, so here we go. We plug it in. Which one is my y2 value? Negative 2 is y2. So remember, this is your formula. Okay? So y2 is negative 2. Sorry, I'm just kind of labeling up the sequence. Negative 2 minus what? Negative 2. Did y'all catch that? Double negative. Over 7. That changed to a plus. 7 minus 1. What's negative 2 plus 2? 0 over 6. Anytime, guys, I cannot stress this enough, anytime 0 is a part of your slope, this is not your final answer. I can only give you half credit on a test and no credit on a quiz. Because anytime 0 is in your slope, you have to recognize the placement of it is very important. If it is in your numerator, that means there's no change in your rise. That means the points are next to each other. That means it's a horizontal line. And going back to the beginning of your notes, a horizontal line has a slope of 0. So you will specifically say slope is 0 and this is a horizontal line. Okay? Something that's easy to memorize. When 0's in your numerator, when there is no change in rise at all, that means it's a horizontal line, right? Because there's no change in your rise. So that means the points are right next to each other and it is a horizontal line. So you could probably guess what's going to happen when 0's in your denominator. It's going to be a vertical line because there's no change in your run. All right, so hint for the next one, go ahead and find your slope for the second one. All right, here we go. Plug it in. -5. All right, there's your sequence again. -5 minus -3 over, what goes in the bottom? -3 minus -3. Man, I got a lot of double negatives there. What happens to my double negatives? Yep. What's -5 plus 3? What's -3 plus 3?
0.
This is not your final answer. This would be if it was a typical slope problem, but because the 0 is there, you've got to take it one step further, because how do I know that you know the difference between 0 slope and undefined? When the 0 is in the denominator, that means there's no change in the run. It doesn't go left or right at all. That means the points are directly vertical. This is an undefined slope, which is a vertical line. This will make a lot more sense when we get later in the chapter and start talking about functions and whether or not something's a function. All right, but vertical lines will have an undefined slope. So if this shows up on your homework, guys, do not leave it 0 over whatever. You have to clarify. Does that mean your slope is 0? Or does that mean your slope is undefined? And what kind of a line would it be? All right, that's everything you need to know for part 1. Whew. Okay, we're done with part 1.